Welcome to Soft Computing series. This video is on operations on classical sets. Before starting with operations, let's see some basic terms. That is about classical set. A set is defined as collection of objects and the objects share certain characteristics. So a classical set is collection of objects and objects have some properties. Classical set is a collection of distinct objects all having same characteristics. That is, classical set contains different objects having same properties. For example, suppose X is a universe set that each individual entity in a set is called member or an element of the set. So each entity in a set is called as member or element of the set. Let's see operations on classical sets. Let A and B be two sets on the universe X. So let us consider two sets, that is A and B, and universe is X. So there are various operations on classical sets. Number one is union. Union between two sets, it is denoted by A union B. It represents all the elements in the universe that resides in or belong to set A or set B, or both the sets A and B. So this operation is also known as logical OR. That is, union is also known as logical OR. So the union can be represented as A union B equals to X such that X belongs to A or X does not belong or X belongs to B. So this is the Venn diagram which shows A union B operation. So this is the diagram where X is the universe discourse. This is set A and set B. So A union B will be all the elements from set A and set B. Second operation is intersection. The intersection of the two sets, that is A and B, is denoted as A intersection B, and it represents all the elements from the universe that belongs to both sets A and B. This is also known as logical AND. So it can be written as X such that X belongs to A and X belongs to B. So here AND operation is used. So let's see the Venn diagram of intersection. This is the universe X. A and B are the two sets. So A intersection B are the elements which belongs to both set A and set B. Now let's see the third operation, that is complement. Complement is denoted by A bar. So the complement of a set A is defined as the collection of all the elements in the universe that do not reside in the set A. That is, it can be written as in curly brackets X such that X does not belongs to A, where X belongs to capital A, where X belongs to capital X. That is, in the Venn diagram we can see X is the universe of discourse, A is the set. So A complement will be all the elements from the universe except from the set A. That is, A complement will contain all the elements which belongs to capital X universe, whereas it will not contain elements which belongs to A set. Let's see the last operation, that is difference. A difference B is denoted in this form, that is set A with respect to set B. So this is collection of all elements in the universe that reside in A and do not reside in B simultaneously. That is, it can be written as in curly brackets X such that X belongs to A and X does not belongs to B. The Venn diagram shows this is the Venn diagram where X is the universe, set A and B. So the difference will contain all the elements from set A, and it will not contain the elements from set B and the universe. So this is the difference operation. In the next video, I will show you example based on the operations of classical sets. Thank you for watching.